Dear guests, my name is Boaz Golani. I'm the Vice President for External Relations and Resource Development and the professor at the Davidson Faculty of Industrial Engineering and Management. It is my pleasure to welcome you to one of the highlights of this year's board. The overall theme of this year's Board of Governors is Technion of Things, TOT, which rhythms with IOT, Internet of Things, and is aimed at highlighting the fact that Technion is at the forefront of the world's digital revolution. The panel discussion today is set to provide real content to this slogan. The environment around us is quickly being filled with digital devices in our cars, our streets, our homes, our home appliances, in our wearables, and in short, everywhere. Each one of these small devices is an engine of data, and together they generate unprecedented quantities of data that are then transmitted to remote servers that collect, exchange, and analyze the data. This digital revolution creates new and quite formidable challenges to our researchers. The Technion is globally recognized for its IT capacity, with world-renowned experts in the faculties of computer science, electrical engineering, and many more. Here, I should proudly mention my affiliation with the Faculty of Industrial Engineering and Management, the Technion's home to the newly launched Data Science and Engineering program, the first of its kind in Israel. No wonder then that the IT is also at the heart of our joint project with Cornell University in New York. But technology is not all about devices. It is also about people. So when we say Technion of Things, we mean to encompass both the people behind the things and their interaction with these things. To help us understand better this new scene of technology, I would like to invite our panelists to the stage. I will start with the panel moderator, Deborah Estrin, a professor of computer science, associate dean at Cornell Tech in New York, and a professor of public health in the Weill Cornell Medical College. She is the founder of the Health Tech Hub in the Jacobs Institute and directs the Small Data Lab at Cornell Tech. Previously, Professor Estrin was on the UCLA faculty, where she was the founding director of the NSF Center for Embedded Network Sensing. Deborah, please. Along with her, the other distinguished panelist, Dr. Stuart Feldman, head of the Schmidt Sciences at the Schmidt Philanthropies Foundation. He is responsible for defining strategies, initiating programs, and managing grants in science-related areas. Dr. Feldman is former Google VP of Engineering East Coast and former Vice President for Computer Science in IBM Research. Stu, please. Professor Danny Raz from the Faculty of Computer Science at the Technion. Professor Raz's main research interests are the theory and application of efficient network and system management. Danny, please. And last but not least, Professor Yoav Etsion from the Faculty of Electrical Engineering at the Technion. Professor Etsion's main research interests include computer architecture, reconfigurable architectures, hardware and software interplay, and parallel programming models. Thank you very much. And Deborah, the floor is yours.
Thank you so much. The floor isn't mine. Now is yes, now it's mine. Thank you so much. It's a pleasure to be here again. And what I'd like to do is start by having each of the members of the panel say a few words. I have a timer. We'll have some questions, and we'd really like it to be questions from you as well. Hopefully you'll ask us more questions than you asked our illustrious president. We're counting on you. So let's begin with Stu.
Thank you, Deborah. I'll just sort of set the stage with a bunch of definitions, comments, and at least my view of why the Technion is a natural hub for this revolution that is well underway. But first of all, the term Internet of Things is basically a marketing term, and there is no technical definition, so we can just make it up as we go along. Basically, the Media Lab at MIT coined the term between 15 and 20 years ago. It raised a good amount of money, which is a good thing. However, if you look more seriously, what we're really talking about is the world of interconnected devices. And device can be almost anything, everything from a whole airplane or a whole building to a tiny thing that's a few microns on a side. The scale is wonderful. The implications of it are really complicated. Also, just a reality. IoT, because it's not well defined, is a sort of hegemonic topic. It covers pieces of everything, which is the reason why you will find researchers and entrepreneurs in an amazing number of areas doing IoT plus X, where X is them. And this, I've been reading a blog on IoT and law, and that has 4 subsections. So, and it's all lawyers. No, it's all, that's good, I guess. So if you ask, what are we talking about? Well, there's many dimensions for the discussion. Many people think first about sensors. How is that bridge doing? What temperature is it right here? But the other side is actuators, actually doing something. And that is the sort of challenging end, doing things into the environment, not just sensing it. Another dimension is whether you're thinking of these devices as remote-controlled objects or whether you view them as autonomous. In other words, do the objects simply provide data and take orders from somebody else, or are they acting pretty much under their own steam? Well, nobody has a good legal context for the second part. But the technical issues are really important. And if you start asking about objects that are in uncomfortable places, I'm currently very interested in ocean science. Things that are underwater, deep underwater, are not controllable because you can't get any signals to them. What does that mean? Are the devices mobile? Everything from a cell phone to a drone, or are they just attached to a bridge or not? Well, it turns out that technically there are lots of different problems. Usually something that's sitting in space, you can get to power to it more easily than if it's traveling. But the networking problems are far more exciting once you say that you have small mobile objects. And then, by the way, are you talking about living or non-living substrates? In other words, instrumenting the body of a human or a cow is actually quite a different set of questions practically than for people, non-people. So Deborah is probably one of the world's experts on this important problem. So why the Technion? Why the TOT label? I think it's actually a superb discussion because the topics of IoT genuinely touch on most of the areas in which the Technion is expert. Sensing the built environment, civil engineering, mechanical engineering, is a huge opportunity. And by now it is quite standard to pour sensors with the concrete in large structures. Where are we going next as we try to understand a much broader variety of things that we construct? Basically, every machine either has or will have sensors, of course. You can just say the machine itself is an Internet of Things object, the whole machine, once it's got any network connection. Well, just take a look at what airplanes look like. And by the way, a drone is essentially a pure IoT object. Well, this touches on mechanical, electrical, and engineering, touches on a wide variety of others. Continuous sensing of the natural environment, everything from seismographic measurements for earthquakes to temperature measurements for the climate. This is a very large and immensely rapidly growing subject. I'm assuming that we're going to see sensors on the sub-meter resolution on much of the planet in the next decade or two, not just every kilometer as you got today. And this is continuous monitoring, which we'll get back to. Finally, we're going to have some real data rates, even for simple data. Then interactions with people. Well, everything from knowing where we are and how we feel to providing entertainment. All of the gadgets that people use for digital entertainment are fundamentally IoT objects. They are internet or network connected. They are there purely to interact with you and also to react to how you reacted. So they have autonomous possibilities and then they have centralized possibilities. And then continuous sensing of living things. I'm assuming that by now almost every chicken has a chip of some sort. Certainly every cow did years ago. Well, it's an economic trade-off value of how valuable a chicken is versus how valuable a cow. But RFID tags really don't cost very much anymore. And if you go to a veterinary clinic, they'll more or less force you to get a chip on your dog or cat as part of the deal. Well, this is just the beginning. I mean, this isn't, nobody is buzzing the cat to do something. Let's wait to see how that goes. And then all of these have simply cross-cut all of the fields of math, applied math, computing, storage, data analysis, machine learning. All of these are both fundamental and increasingly focused on the problems and the opportunities that we get. Let me just mention one practical fact, speaking from Israel and its 5 million or 6 million people. This industry is not likely to be centered here because the industry is enormous. So you're going to have to be having very close partnerships. And the obvious American connection is fine. There's lots of really hot stuff, has been for years. The Germans have a very German approach to Industry 4.0, but look at China. I mean, if anybody wants, I'll read you the ad for the 9th IoT conference in Shenzhen. This year they expect 500 exhibitors covering the entire supply chain, all the way from devices to networking to applications, silicon to software. And Shenzhen in particular is a government-supported hotbed of IoT. So the interactions between the technology strengths of the Technion and those hubs in the United States, several cities, our major hubs, are really going to be an important play.
Thank you so much.
So I'll give you my personal perspective about Internet of Things, and I'll do it like a class. I sometimes teach on this stage. So Internet of Things. So let's start with the first word, Internet. What is Internet? And if you ask, professional people like me, they would say, this is like a collection of devices and protocol that would allow to transport bits from one place to another, bits which compose, one bit, and then we have many bytes, and then we have package of bytes which are going, many of them are going from any place to any place. So this is the internet. But if you ask normal people, what is the internet? What would they say? It would, the most common answer for like a bit older people would say, this is what allows us to talk over the phone. Younger people don't talk, they just, text, right? But then they would say, it allows us to text, it allows us to share status on Facebook and stuff like this. So basically the internet is the background or the provider for our virtual life. We couldn't have a virtual life without the internet. So this is what I like about my professional thing, because study the internet, which allow people to connect and provide the technical background for our virtual world. Okay, off, you all know. In Hebrew, off is chicken, but forget about this, and the chips. Things. Okay, so Stuart gave a very, very good, technical detail about the sensors and stuff like this. But basically, things are everything that we touch, right? So the handle of the door, if the door is connected, then also the door would have to talk to some other devices through the internet, which actually brings me to realize that what I do in studying the internet is now, when Internet of Things is going to take place, and it will take place more and more, so I'm not just studying the virtual life of people, I'm also touching the physical life of people. So my job now, as an example of a Technion professor, going to the TOT, is much larger, because now we cover the entire space of our life, virtual and physical. So Internet of Things or Technion of Things is allowing us to make a big impact on the entire way people live in, and not just the virtual world.
Okay, the panel reminds me of the joke about the blind man and the elephant. Everyone sees it from a different perspective. And I see the IoT, this development, this. Okay. I see there's the IoT revolution, and it's wired. Yeah, I see the IoT revolution coupled with the machine learning and artificial intelligence revolution as a means of an infrastructure that can allow us to open a lot of doors and do many, many things, some of which I cannot even imagine, between the cyber and physical world. And in my view, I'm looking, because I cannot imagine all the uses, I'm looking at it from a mostly technical perspective. Connecting very small devices and a lot of devices and all kinds of sensors to the internet provides us with data. And then there's a question of what do we do with the data? How do we process it? Where do we process it? At that small device, or do we move the information and pay some energy to move the data to the cloud and process it on the cloud where we have more compute intensity, we can more compute power? How do we store it? How do we protect it? And with that, I have a sort of provocative example of an IoT device that I did not imagine. I read about it. A company, and I think the device sort of epitomizes many of the problems that we're facing. A company, I think a Canadian company, introduced a sex toy that can be operated using the smartphone, so that couples who are not physically together can enjoy intimacy. So far, it's a very legitimate device. Now, here are the problems that arose sometime later. Devices and your phones, for example, and physical devices don't communicate directly because of the way the internet is built. They communicate through a server. So all the communication between the device and the phone had to go through the company's servers. Now, the company, first, they wanted to store some of the data because they wanted to improve their product and future products. It's not a new thing. Facebook, Google, Microsoft, they do it all the time. All your internet searches are stored somewhere. So they stored the data. And it's not clear how well they protected the data. The second thing is the communication channel between the device, the servers, and the phone. Are they protected from hackers? And there's a whole lot of security questions involved in this. And this also raises some legal questions we haven't thought of. Does the company, by storing intimate information on its servers, does it commit some form of sexual harassment? If a hacker hacks into that communication line, Does it perform a sexual assault? Those are legal questions that we haven't even figured out. As far as I know, there's a class action suit against that company for coming up with a device that is seemingly useful for some. And I think it epitomizes how we need to process the data, or the main questions. Where do we process the data? If you process the data in the device, then that's my expertise on processing, on building processors. Then we need processors that can compute very fast, that can be very intensive, but they need to consume very little power, because we don't want our phone, in my example, but let's say you have a button on your shirt that does speech processing, so you can ask, instead of asking Siri, ask your shirt something. And you need to do some processing locally, and you want that processing to be as intensive as possible, so you won't have to delegate information to the cloud communication channels that are not necessarily secure. How do we secure those channels? What do we do in the cloud? The heavy lifting will be in the cloud, where the massive processing power intensity is located. How do we transfer that information securely? How do we process in the cloud securely? How do we prevent the companies that operate the cloud, like let's say the big five, Microsoft, Google, Facebook, Amazon, and now Baidu in China? They have our data. How should they protect it? How should they use it? Facebook and Google use our data all the time. We see it from our search results, from what the ads that they offer us. And so we have these devices that we cannot even imagine, and a lot of technical questions. And as I said, my expertise in how do we, in order to prevent some of the security issues, let's try to process whatever we can locally. And here comes machine learning and artificial intelligence. There's a lot of research on that in the world, in Technion. And so we have algorithms that require a lot of computational intensity. So we need to provide them with processors so they can compute locally and not send the data out of the device. So there are a lot of technical, ethical, and legal questions that will need to be addressed sometime in the near future with the respect of IoT.
Great. So you just had me think of a new IoT device that I will request the next time around, which is a IoT device for panelists on a session, so I can subtly buzz them when they're going over their time. Maybe I can adapt that.
They exist already. They're dog collars.
Oh, okay. So I just wanted to add a few words here before we open it up to questions. I was thinking about it on the way in this morning that it's exactly 20 years ago I ran a study for DARPA's ISAT on what was sort of, to develop a research agenda on what was sort of the predecessor of IoT, one of them. And it was on wireless sensor networks. And we did a pretty good job. We did a National Academy study afterwards called Embedded Everywhere. But we got a lot of things wrong. We were sort of doing this advanced visioning, and one of the biggest mistakes we made, I think, was focusing on instrumenting the physical world rather than focusing on devices that people were going to use for other things and then getting data about the world from those devices. So because when you put sensors out in the environment, even if they're cheap, even if they're low battery, there's a certain return on investment of being able to sense that particular millimeter or meter of the world, that it's, the economy of it is very different than imagers, which have a big field of view. An imager, a camera, is an Internet of Things. But for one camera, everything it can see, you get data on all those points in space, rather than just the one point at which you might have something that is sensing something through a physical or chemical interface. So physical and chemical sensing has really evolved much more slowly. I'm delighted to hear about the nanos. project and such, but these things take a long time. They deserve tremendous amounts of investment, but they're on a very different growth curve than things like cameras. The development of imagers, of cameras, of that technology, since the emergence of the first mobile phones with cameras in them, which was well before the iPhones and the Androids, that is a development curve that is tremendous. And at the beginning of that research vision for distributed sensing, we didn't have that sensibility. We didn't think about that if you place a sensor in one place, there's a huge opportunity cost. It's not everywhere else. And once mobile phones emerged, then we started realizing, wait a minute, this mobile phone that wanders around in the person's pocket or in their hand is a source of so much more data, just like the sensors on the cars or on the robotic vacuum cleaners. So as we think about Internet of Things, the research agenda, I think, will both be more practical and more forthcoming in its impact, because we are talking about devices that people want for some purpose, and those devices happen to give us data as well. And we're talking about the devices that are mobile, not only ones that are fixed in space. So I think that one of the ways that the Internet of Things and Technion in pursuing this agenda can really have the most impact is by engaging with the applications of those devices and not being too distant from those applications, not being worried too much that you're getting too close to the applications, and not being worried too much that the theory will be less valued because it's actually application specific. I think one of the things that is most valuable about what we're trying to do at Cornell Tech and at the Jacobs Institute is saying, bringing the application of things close to the development of the technology is going to be of great benefit to both, because you learn so much, you get this course correction, you get so many new ideas and guidance for direction from being out there in the field and close to the application. So many opportunities of now, and it's really the question of where should this, audacious creativity of the Technion students and faculty, where should it be spent, right? Will it be around the Internet of Medical Things, manufacturing, environmental, structural, social, and entertainment? Are we talking about big things or small things? Little devices or cars and bridges? And really, where are the technical challenge? I think a lot of the work that's gone on, that's come out of the big data revolution and machine learning, will come now to move on to being about perception. So moving on from just identification of objects and computer vision to the perception opportunities that come with making these devices smarter. And a lot of the challenges are also around what's the time frame? Where do we focus the energy of an institution like the Technion? How far out? And you can focus sometimes too far out, because then you can't get feedback from the real world and really benefit from what the real world has to teach you. We know that nobody anticipated these applications that we're now proud to somehow have been responsible for, right? They happened. And they happened because the technology got out there quickly and got adapted, and the world found other uses for it. And we need to balance becoming myopic from being too tied to those applications and being willing to be engaged with the real world. So with that, I'd like to have a few, just start off with some questions to the members of the panel, and then hopefully you will think of questions of your own, or even, dare I say, comment. So, yeah, I got those anyway. So, Danny, maybe you can start on where you think, you gave some initial comments, if you had to choose to initiate a couple of big projects at the Technion in this space, where would you start?
So, I mean, it's good that you're talking about application, about companies that come up with applications. And we are in academia, so we actually have to somehow take advantage of what we do good. And what we in the Technion and in the IT area, both in IE and CS, is combining the theoretical aspect of things, not Internet of Things, of everything, into the practical world of systems, for example, in algorithm. So what we should do is we should look ahead. We shouldn't really chase those companies. I mean, they will pop up and they will do their things, which is very good. But we should come up with a theoretical aspect and combine the theoretical aspect to the real world in a way that will give advantage to us, to the company that we work with, to the state of Israel, etc. And this is what we do best, both in the area, let's say in the area of medicine. Of course, we're not competing with you guys, but locally there is a very strong medical department, and there are very strong connection, let's say, between the computer science department and the medical, say, in image viewing, image processing and stuff like this. Taking this further, and there is a very well-known Israeli company that produces this pill that you actually takes the camera into your stomach and produce pictures, and now we have machine learning that do the analysis by themselves. So what I'm saying is that our advantage is the combination of the different, and aerospace is another example, and the connection between IT and aerospace in drone and stuff like this. So the connection or the combining together the different departments in the Technion to this, through this base of computer science, and coming up with a very strong theoretical ideas that go into practice. And what you say is getting the people who develop the application and the people who understand the technology together is actually the solution. If you bring them together, you get more power. So 1 and 1 gets 7. And this 7 is going to be the winning 7.
Great. Yoav. So you started to talk about and mentioned the cloud behind the Internet of Things, and you mentioned some of the issues surrounding security and privacy. But of course, we need the cloud, even with local processing. The models don't get developed if everything just stays local. You don't get the benefit of the aggregate to figure that out. So how do we?
Okay, well, the cloud, we all view it as a sort of an opaque thing, but it's essentially warehouses filled with computers that serve the backbone for this entire revolution. They do the computing of all the data that arrive. And if I remember the numbers, the rough numbers correctly, the estimate is that they currently have about 3 billion mobile phones or smartphones in the world, and the expected scale of the IoT world is over 30 billion devices in the next few years. I think it's by 2020 or 2022, something like that. So we need to scale this backbone to be able to process all the data. We need to think of how to do it. And I think that the industry is very good at perfecting existing technology, but the prerogative of academia is to look 5 or 10 years in the future. We don't have investors breathing on our necks in order to get the revenues and get profits. So we can have the stomach to look further into the future. So if you look even at that problem, how do we scale the computing? Just adding more and more computers is, well, sort of the obvious solution, more power, but it's not necessarily scalable. So one key problem that we face today is how to compute more efficiently. And that's something Boaz introduced me as a member of EE. I'm actually a member of both EE and CS faculties. And the EE and CS faculties have this notion of what is computation and how do we build processors. So we need to think of how do we build the future processors so that entire backbone and that entire infrastructure can scale. Today, virtually all processors use the same computing model. It's called the von Neumann compute model, named after John von Neumann, who developed it in the 1940s. And virtually all computers, from your mobile phones to the cloud, use that model. But that model is very inefficient, both in terms of performance, but mostly in terms of the energy that it consumes. If the cloud providers will have to provide, if they have to provide 10x compute intensity and they have to pay a 10x electricity bill because of it, then the economics won't pay off. We'll need to pay more for all the services. So we need to find new ways to compute, to process all the data. The data is increasing exponentially. We need to increase the compute power exponentially without increasing the electricity bill. So we need to find new ways to build processors to do that. And I find that's a fundamental problem that is at the base of this entire ecosystem. Because if we have better processors, we can do more of the computation locally and not send it to the cloud. And then the problem for the cloud somewhat alleviates. We can use more secure protocols and more secure methods to transmit the information because we have more energy, more compute intensity that can be battery operated at the edge and more compute intensity at the cloud. So the communication can be more secure. We can do more about storing the data more securely, encrypting it with more advanced methods.
This is my virtual version.
Okay. So I'll stop here and respond.
So I think it's time for some sort of an argument, right? Otherwise, it's not interesting. So I think you made a statement, which is that industry is good at perfecting things, optimizing things. You made some comment of that sort, and that it's on the university to do the farther-looking research. I don't know, maybe that was true before you were born. But I think since you're born, it actually isn't true. And it's pretty confusing for engineers and technologists, for PhD students, for professors of all levels, for funders to figure out what the hell to do in the university and what to do outside. And particularly when you look at the amount of data that the larger players have, the big five and so on, it's very hard to compete. And for those of you who are anywhere near computing, if you try to get a PhD student these days interested in research, if you can't offer them a huge data set to study, they are not interested. Because if they don't have a large data set, they're not going to generate publications at the same rate of all the students who do have access to those large data sets. And so it goes. So there's an interesting question here. What should we do in this space? How do we work with the entities that have the larger data sets? Are there mesoscale problems, right? If Google is only interested in problems that are at Google scale, what about all the problems that aren't at Google scale? The things that are more individualized, personalized, maybe even a bit concerning for them to get close to class action lawsuits and things of that sort. So how do we find the right scale of a problem where we're solving important problems? And I'll add one more rant to this thing. Venture capital. We all love startups. We all love huge growth and return on investment. Well, there are lots of good problems in the world that are good businesses, revenue producing, and solve actual problems that human beings have that don't deliver that kind of return on investment. And we're raising generations of students who only have interest in these sorts of problems. And there are all these other problems in the world that not charities, not social entrepreneurship, actual commercial entrepreneurship, that don't get addressed by the Googles and the VCs. And there are opportunities, I think, particularly in the Internet of Things space, to build specialized medical devices, teaching devices, driving devices, things that those larger players with a very different return on investment won't touch. So, argue with me.
Hello? Well, I guess I probably won't. I will be more controversial. If I look at the history of computing in the last while means quarter century, most of the pressing advances outside the pure theory regime have happened in companies. The job of academia is to figure out what that meant and then come up with a really replicable theory. So you have 10 companies and 8 of them fail. One of them does it real well and one does it sort of well. The job of the research world is now to say, what was the thing that they did that really was the point, and all these failures, they were just stupid because they didn't understand the question. So I'll be even more strong here in saying, in this space, I would be urging rapid interaction with people who are building, God save us, networked sex toys. I can think of better businesses, but okay, maybe not. So back to your exponential, sorry. But anyway, that actually may be a really good tactic, because getting what's special about industry, startup or classic, is focus on doing this thing and making it really work no matter how, as opposed to getting it nice enough that you can describe it. So the interaction with people who actually have a different mindset of why is this, what is the proper framework, and how can we then do it better for 15 other people, is a great interaction. By the way, I began my career in the golden days of Bell Laboratories, and in practice, that was the internal model. Problems came to research that were really hard, and then they turned into signal analysis, information theory, and other small topics.
So it just happened that 3 years ago I went on sabbatical and I opened a branch of Bell Labs in Israel. So Bell Labs is still alive and is present in Israel. And I think that we should somehow replicate what was done, say, in Bell Labs when they invented Unix. I don't know if you know Unix, which is the base of Linux, which is the base of open computing, was invented by a company, in AT&T, in Bell Labs. And we should proceed in this way, and also Google. Google started with an idea of search, which came from people from the university, okay? Mm-hmm. So I can distinguish between, Facebook, which doesn't have much of a technology background. Now they do when they have the data center stuff, but did not have a technology base, and Google, which did have a technology base. And I say, the stuff that would come from here should have a technology aspect and should have a very deep technology aspect together with the understanding of the application, okay? So communicating and talking to the application guys is very important. Having your student being out there and come back is very important, but the fundamental understanding of the processes of what is computing, of what are systems, how you connect system and computing is something which allow people that come out of here, start their own stuff in a good way, not like in a superficial way that could, attract some attraction for hype of things and then vanish into the sea of the ocean of bad ideas, okay? So this is where we should actually do, and we are doing well, but we should emphasize this fact and do better and encourage people to continue to grad school and continue to understand, because only, okay, so now I know how to program, I can do, some scripts. Let's go out there and do a startup. Some of them would succeed and would make a lot of money. If money is the criteria, okay. But if they really want to change, and I think the criterion is impact. What we want is we want impact. And we can do a much larger, we as a Technion can do a much larger impact in higher level if we play our cards correctly. And our cards correctly is, taking the fundamental stuff that we know, we as, generally speaking, all the people around here know well, educator teaching our student, and combine this with the real world and real system. This would give us a step ahead of the rest of the world.
Okay, I fully agree with Danny that we need to collaborate. Academia and industry should collaborate much more closely. But I disagree with Stuart that a lot of the innovation, maybe I don't know, most of it, a lot of the innovation that we see today came from academia. Danny mentioned Google. 2 grad students in Stanford came up with an algorithm and commercialized it. Facebook, to few students, it's debatable who are the students beside Mark Zuckerberg are, but a few undergrad students in Harvard decided to build something for their own and saw that there's commercial merit. In the computing world, NVIDIA is a company that makes graphics processors, and it currently is at the heart of the AI revolution. It powers most of the AI revolution. Now, how do we get from graphics processing to AI? NVIDIA made graphics processor and was very good at it, but a few professors thought, wait, if they're very good at graphics processing, and graphics processing has a lot to do with linear algebra, can we use those processors for linear algebra? And opened an entire new ecosystem for that company, for NVIDIA, who didn't even think about that model. So there's a lot of impact, and now I'm looking scarily at Deborah if she doesn't stop me again. There's a lot of impact on academia. Another aspect of that is that historically, well, I guess I'm the youngest in this panel, but old enough to have seen the companies, big companies who invest in research go down. And usually, for the big companies, as long as the business model works well and there's the cash cow is working, they invest a lot of research. Bell Labs, for example, was, back in the days of AT&T Labs, was a huge research center, and it sort of dwindled. Then IBM, and once the cash flow dropped for the business side, the research was dropped. More recently, Microsoft. When I was looking for a postdoc, Microsoft research was the big deal. But since then, Microsoft had to close almost immediately its research center in Silicon Valley, about half of its research facility, because, well, Microsoft doesn't have the revenue stream to support it. Today, it's Google who support a lot of research, Facebook, and VMware, another company who deals with cloud. But who knows what will happen to those companies. So yeah, they control the data, and we need the data, and we need the collaboration to work together. But if we look long term, we don't know which company will do the research. So academia is here to stay and is longer. Sustains longer.
We're not supposed to make fun of it. This shows that you're now tenured. We're allowed to harass you. So, can I get the microphone back? Great. So I wanted to take any questions, comments from the audience? Yes?
So coming from another type of these companies, from Yahoo Research, where I hope is not going to entirely die, I totally agree with what Deborah said, that in that specific field, it's not true for every field, right? Let's say in computer science, I come from computer science, theory is key, super important, and the Technion is ruling, and it's awesome. But we are talking about Internet of Things. In that field, what Deborah said, that you need like fast turnaround, and going back to the data, and getting applications, and pivot, all the time pivot, I think it's really key. So if the Technion wants to be really a key player there, it needs better data sets, it needs access. We give for free to academia only at Yahoo this web scope data set. It's not enough. I hope the other companies will do the same. Maybe companies will rise and fall, but other companies will come back, will develop as they get stronger and they understand the importance of academia. They will develop more research. It's kind of maturity. Facebook is going there now only. But I'm not sure the Technion is ready. There's still not that much respect for application-driven research. I do immodestly remember I was the second PhD student having a thesis in software engineering, and people were making fun of me at the time, 30 years ago, because, who cares about software engineering? I really think that we at the Technion, and from the governor side, we need really to encourage the entire administration to interact more with industry, exchange students, graduate students, not undergrad. Undergrad needs to study. Grad students should go to summer internship, work on the data, and you guys, be with an open mind. So do you have any plans?
Yes. I can't physically bring this to you because this wasn't planned. I just decided we should have some interaction.
It's quite simple. When are we becoming a thing?
Yeah.
In this environment of things, we become literally a thing.
Yeah. So have you read Harari's second book? Homo Deus?
I was watching my children using the ways. It's wonderful device, but they lost orientation.
Yeah.
Totally. As the word fire crossroad
Yeah.
they didn't know where it was.
Yes. Yes. Do you want to say some things about the social?
Yeah.
Yes. I'm sorry. I was so engaged in listening, I didn't repeat it. When do we become things? And when do we begin to be defined and influenced in a way by the devices? And then you use the example of the application Waze, and with people's increasing dependence on navigation applications, they lose a sense of orienting themselves on a map without that assistance.
Well, first of all, there's a very long history of that worry. You'll find Plato being very strongly opposed to writing because it ruined memory. So we always worry about losing one ability in exchange for another. However, yes, we are going to be far more instrumented things. And for many reasons, this will turn out to be advantageous. Everything from caregiving and analysis of medical to actually being able to provide you information. Google Glass as a commercial failure is a given, but you are going to have instrumented, augmented reality in one form or another, which will indeed, in my case, I hope, tell me who it is I'm talking to because you introduced yourself 10 minutes ago, but I've forgotten already. So you're going to see all of those instrumentations at least. The question, if you have an insulin pump, you are already an actuator-driven Internet of Things. So the answer is yes. And by the way, when I was giving futuristic talks 20 years ago, I made a similar error to yours. I was predicting that by now we would already have 10 to the 12 sensors, not just 10 to the 10. Off by fact 2 orders of magnitude, but I'm assuming that we're going to fix that over the next decade.
So just one comment before you go forward, which is just because people have been worried about similar things for a long time doesn't mean we shouldn't still be worried, and doesn't mean we can't try to choose what to design and what to do and how to use technologies. And it's a time of reckoning for us as designers and as members of the society, choosing what skills and such we want to give up and what we want to augment.
I think that in future panels like this, you need at least a sociologist or a psychologist. I look at my grandchildren. I'm worried. I mean, your president is tweeting all the time and they copy him. Our whole way...
Copying them.
I wouldn't say much about it, but I take the fifth here. The issue of communication between people, limited to such and such a number of words, is going to affect cognitive performance. There is no doubt about it. So I believe that it's not only an issue when we are going to be thinking, how we are going to communicate with each other, how we are going to convey ideas. So maybe Plato was worried that writing is going to distort our memory. I'm not so sure about tweeting, what it's going to do to our memory.
May I make one? Let me point out that if you take a look at sort of the last 20 years of history of people talking to each other, we had a high point of email, which meant people actually had to be semi-literate to write, and the amount of writing being done in the email-only era was actually very impressive. The tweet is only one of the responses. You've got Line, which specializes on just sending emoji. But the real revolution in the past 5 years has been images and videos. People communicate, if you will, by a much broader band communication than the word stream. So now, is a cat video a way to analyze the categorical imperative? Maybe not.
So if I can comment, I think that we still have an edge, we still have knowledge, we still have deep understanding, but maybe the system should adjust to the fact that the companies, or the big companies, that is the big five, but even any other company, they have data that we as researchers need. And maybe we should pay. I mean, it's not the case that, we have this bright idea and the company should come and pay to us to get it. We also need stuff from them. So the system is becoming more complex, and maybe we at the Technion should pay attention, and maybe, as we like to be the first in the field, be the first over here and change maybe our IT rules and stuff which allow researchers to communicate better and work better with the local and generally speaking industry in order to basically have this large impact that we would like to get.
So just an interesting riff on that before we take another question. We used to get industry donations, cash, which is what we would always prefer, of course, but also equipment, right? So maybe what we should do is, from that perspective, be able to value the data sets that are made. Now, there's proprietary issues, and sometimes what you need to do is exactly what you suggested, which is basically the students go and become employees of the company. They have access to data. They do their analysis. They publish outside. There are all sorts of ways we need to be more creative here, because data sets that are generally made available aren't worth that much and for very long. And then I just wanted to address one thing that's certainly something we're doing at the Jacobs Institute and at Cornell Tech generally, is we have sitting together, we effectively act like a single faculty, people who come from information science and social science and business and law, as well as the engineering disciplines. And where our students are exposed to that, both the master's and the PhD students, and in our discussions of these problems, we're really coming to it from that perspective. One of our colleagues, Helen Nissenbaum, really is a founder of an area that's referred to as values in design, in which you're really thinking through how to, in a systematic way, bring in questions of values and trade-offs and such into the design of technologies and systems.
If I may just make a comment. I happen to think that is, this is not a paid advertisement. I actually happen to think that this arrangement is superb, because too many of the questions, I read too many legal opinions which are well unanchored in reality. And of course, we computer guys just do what we feel like and hope it's legal, and so forth. So that is a brilliant way to do it. If I may comment, the odds of getting a full Google data set, where would you put it? Show me your exabyte spare data. Remember, the big guys who do big data, the unit is now exabyte, not petabyte, and no human has an exabyte anywhere. But if you think about working closely with meso-computing as opportunities, in other words, small companies that are growing, but not teeny companies, if you are closely working with them, you are inside and you actually have access to the relevant IoT-style data, even if you can't get all of the tweet streams pre-sorted. So and Twitter is one of the few places you can get the raw data if you can handle it. So strongly I urge, once again, working closely with the people who are doing major applications, partly because you're inside in a way that you're not going to be with the big guys.
To follow up on the comment that Deborah made a couple of minutes ago and challenge the panel with another question. As this revolution is all over us already, we ask ourselves whether the structure of us as a university, our departments, our programs, etc., is it the right structure? Should we continue to stay with the departments we have, with the programs we have? We know that in Cornell Tech and in Jacobs, they do business differently. Are we prepared for this future onslaught of technologies in the best possible way, in the way we are organized today?
So, I think that people make the difference, not the rules and the regulations, okay? So I don't think that, coming up with this multidisciplinary, whatever, research center with some, some bureaucracy and rules and stuff will solve or create anything better. Okay, what I think is that the atmosphere and the management should be relaxed and say, this is good, we like it, go and do it. Okay, I'll give you a bad example, okay? My friend here is now, like he said, he is a member of 2 faculties, okay? CS and computer science. Now there are some things that Technion bureaucracy cannot handle, 2 departments. So they have to put, there's only 1 name in the department field of a faculty member. No, there's no way to put 2 of them. And this is weird, but this is true. So what I think is we shouldn't really come up with a new way to put 2 names. We should have more flexibility and allow people, because we are talking about people and we're talking about not the people on the stage, but people in this building and in this institute are very smart in general. So they can come up with very, very good idea, and we should allow, we as the management should allow them the freedom to interact and come up with bright ideas and way to do this interaction and not stop them. And this would make us, especially as Israelis, like to, take the rule and go around a bit, if you notice. And this, we should make it an advantage, not a bad point.
Stu, and then I'll take another.
Okay. Well, I'm not going to even come close to addressing your actual question, having heard the president. I'm sorry. If I summarize your talk, you get 7 A's and 1 D. Well, you're still here. It's a D. But okay. But anyway, so I'm not even going to address that. But if I look at both research labs that I know, foundations, various other strange universities like MIT, there are 2 different approaches, which I'll just simply summarize as hammers and nails. Academic departments are fundamentally about hammers. Create a hammer that really does something in particular, like, a really good hammer is called mathematics. I'm not talking something simple here. But then there's the nail approach, which says, MIT has at least 2 institutes for integrated cancer research, and any hammer will do so long as you can pound that particular nail. And ditto, IoT, if you will, is a nail. And now the question is, how many hammers can you throw at it? And that may, and this doesn't say you don't want now to build lots of stronger hammers, which are the academic disciplines. And so I can debate some of the history of various statements here, but the crucial fact is that the result of previous questions resulted in the academic foundations that generated the next generation, and that is absolutely correct.
And at Cornell Tech and at Jacobs, each faculty member's tenure is in their home department, and it's actually a very important element of it. So we have another comment.
Okay. First, I'm going to coin a word. IOTable. Internet of Things. IOTable. So a few years ago, we wouldn't have thought that owning a car was IOTable until Uber Technologies made it much more efficient to call Uber than to pay the garage, pay the car in New York City, and park the car. So it became IOTable. So my challenge to academia is, what is IOTable? Because, for example, right now my wife and I are trying to do a small renovation at home, and our renovation construction is not IOTable right now. It's a nightmare. So architect and contractor, Kablan, etc., it's not IOTable. What is going to be IOTable in the near future? Should I wait a year to do the construction? And it's IOTable. That's the challenge to academia, I think.
I'd like to comment on it. I think that what you're suggesting is more of an economic system, an economic question. If there are many, I'll call it users for the lack of other terms, many clients like yourself who need this service, some company will start it, some company will deliver it, and will deliver it develop it much faster than academia can. Academia can think of what the infrastructure would need in 5 to 10 years and chase that. And I fully agree that academia should work closely with industry, learn the data set, learn the problems. But I'm not sure that what you're suggesting, what is IOTable, is an academic question. It's an economic question, in my view.
Why is economics not academic? I guess I missed something.
He meant non-technical. he meant non-technical.
Sorry, so hell of a lot more technical than most of the chemical stuff I read.
He meant not a question of technical. I don't agree with him anyway. But
I'm sorry. Yes, that's what I'm here for. Anyway.
Yeah.
I would chime in.
It's both.
I've said too much.
Right?
It's both economic. Well, I'm from Technion. We don't have a big economics department here, so I'm looking from a technical perspective. But it's, I didn't say, I said a big economics department.
Great, but it's small.
So I'm looking at it from a technical perspective. I'm not an economist.
Okay.
No, but
So a final set of comments, because we were just given the 5-minute hand wave. Yes, go ahead.
So going with what you said, so hover or taxi is a easy problem because you have a consumer and people who produce the service, right? But if you have three, even the 3-point problem in physics is much more difficult than the 2 problem. And here, let's take the example of fresh products. If you want fresh product from the people who grow them, you have to go through somebody who delivers them like a car. So you need the taxi, the product, and the consumer. And now it becomes a really hard problem. And there are no startups that do. I mean, there are few, but they fail. So here we go from 2 to 3, and it's like in many computer science problems, when you go from 2 to 3, the problem becomes NP hard. And when it becomes NP hard, you need more brain into this problem. And this is, again, where I see the Technion coming into it and building the hammers that could be actually used to nail this problem.
I assume you know there's a major debate among economists and sociologists on the question of whether automation is or is not going to devastate the current job market. A not very credible but interesting, well-known paper from Oxford 3 years ago ended up suggesting that in the next 20 years, something like 47% of all jobs are at risk. Better studies say only about 20% because you reallocate the tasks. The problem with your house renovation is probably that you don't have a standardized house because we don't have any. And so it's been hard for low tech to figure out what to do. With better technologies coming out of learning, so I'm in the middle of having my house painted and rebuilt to parts of it, unfortunately. Yes, it's amazing watching people using intelligence rather than rote learning to do things. Well, it's good to see, except it's not plannable. In 20 years, those problems will have been automated away. Now, the question is whether they will be in 5. And the economic mechanisms, as Danny points out, it's much easier to do 2-point coordination than endpoint coordination. But then again, you don't need the optimal solution. It's good enough if it's 99% of it. So there's some hope. But anyway, I'll just say thank you very much for the fun of the panel. And seriously, this is a great area both for Israel and the Technion because there is rapid change. The drive for entrepreneurship is going to be a major fact that is a wave that ought to be great for Israel. The fact that getting these things right does depend on deep science and deep engineering knowledge, which must grow rapidly. And the Technion is a deep well of such. And now if you can get good interaction loops, this could be a wonderful major direction for the Technion, applying many hammers to many nails.
Those are great words to end on, so let's declare success.
I want to thank our panelists. As you can see in the poster that we prepared for this event, They allowed us to open their minds. We didn't know what to expect, what would come out of it. So as you can see, all kinds of stuff came out of it, and not everybody agreed with one another, and that's part of the fun of being in university. So again, thank you, each and every one of you, for sharing your wisdom with us.